Hello everybody, welcome to video 8.3. We're going to be talking about divisibility tests. The book covers a handful, and I'm going to cover a couple more that are not in the book, just because I think they're useful to know. You won't see them explicitly come up on anything they're going to be doing, but I think I think knowing them will be helpful. So I'll point out when we sort of cross that line over from what the book expects you to know to what it's not that I expect you to know. I just think it'd be helpful to know. Anyway, so let's get started. So what do we mean by divisibility test? If I want to know if a number is evenly divisible by a number, it'd be convenient to be able to do that by inspection, and by that I mean by just looking at the number and being able to determine it, not having to get a calculator and type the number in and then hit divided by whatever number and seeing if it comes up as an integer quotient or not. In a lot of cases, the numbers that we're working with are going to be long enough that entering it all in it's more work than we want to do. If we have an alternative of just looking at the number and being able to say yes or no. So this is what a divisibility test is. So we're going to go through some basic ones. A lot of these are going to be ones that you already know. I'm going to assume that everyone already knows the rule for 10, for 5, for 2. Real kind of fundamental ones, but we'll go through and talk about them and talk a little bit about why they work as well. So the test for 2, we've already sort of mentioned. We mentioned it already when we were talking about odds and evens. So this is sort of like I said, that section is sort of a launching point for this. So my test for 2 is simply going to be to look at the ones digit. So I'm going to look at the ones digit. If it is a 0, 2, 4, 6, or 8, then it is divisible by 2. If it's a 1, 3, 5, 7, or 9, then it is not divisible by 2. That's it. If the ones digit is even, then the whole number is even. If the ones digit is odd, then the number is not odd. And we talked about this already. The reason being, if I take a number 5, 6, 3, 8, all of this 563 is 5630. So we know it's a multiple of 10. So since this is a multiple of 10, we know this has to be divisible by 2. So this is 563 times 10, which is 563 times 5 times 2. So I can break that 10 into 5 times 2 and then use associativity to group that 563 and the 5. So I see this is something times 2. So I know that anything that's a multiple of 10 is already a multiple of 2. So this is all I have to check, because I know that this part is divisible by 2. I just have checked if this part is divisible by 2. Again, the rule itself, you probably already know why the rule works. Maybe you do, maybe you don't, but just a quick overview of why it works. Now, our divisibility test for 10 is very similar. We're going to check the ones digit. If it's a 0, then we know that the number is divisible by 10. Everything else means it's not. So if we look at our number from before, 5, 6, 3, 8. So we saw that this is already 5, 6, 3 times 10. So we know this is divisible by 10. I mean, this should make sense. All of that stuff beyond the ones place is a multiple of 10. It's something times that tens place. And we could write that in expanded form, where this is 5 times 1,000, 6 times 100, and then 3 times 10. But all of these places, all these place values, are powers of 10, so we know they're also multiples of 10. So there's no real advantage to writing it out in that expanded form unless you just stylistically want to. But we know all this is divisible by 10. Now this 8 is not divisible by 10. So if I were to divide this by 10, then I would actually get this as my quotient remainder form. I would get 563 times 10 plus 8. So I have a remainder of 8 left over. Whatever is in the ones place is going to be my remainder when I divide by 10. So this is not going to work. 1760. On the other hand, we see the ones place is a 0. So we know this is divisible by 10. This is just 176 times 10. So we know this is divisible by 10 with no remainder. So now we have our test for 5. Same sort of deal. We're going to check the ones digit. If it's a 1 or if it's 0 or a 5, then we know it's divisible by 5. Everything else we know it's not divisible by 5. The reasoning follows suit. This 563, we have already said, is 563 times 10, which we know is 563 times 2 times 5. So I can split that 10 into a 2 times 5, and now using associativity, group the 563 and the 2 together and get this times 5. So we know that everything tens digit and beyond is all a multiple of 5. So we just need to check the ones digit and see if it's divisible by 5. If it is, then the whole number is divisible by 5. If it's not, well, then it's not. And so only 0 and 5 are going to be divisible by 5. Be careful. Sometimes students get a little confused with this because they think, well, 0 can't be divisible by anything. And no, what we have to watch out for is we can't divide by 0. So dividing by 0, no good, but 0 evenly divisible by everything as far as we're concerned. So this number would not work. If I compare this to 1765, so now again this 176 times 10, this is times 2 times 5, so split the 10 into the 2 and the 5. So we know this is divisible by 5. This 5 is also divisible by 5. So to show how this sort of works, I could use the distributive property, which we haven't talked about in a while, and take these 5s out. And so this would be 170, oh, I forgot my 2. This would be 176 times 2 plus 1. So when I distribute out this 5, I'm left with the 176, and then 5 divided by 5 leaves the 1. So I could figure out what this number is if I wanted to, and then that gives me this factorization. 5 times what gives me 1765, or it gets, lets me see this quotient when dividing by 5. But for our purposes, it allows me to see that this number is divisible by 5. I can write it with 5 as a factor of the number. So I can use this form. It's not necessary. I just want to give you some idea of why this rule works. But for our purposes in this class, is just knowing what the rule is most important. So those are all the tests that the book covers, and so the rest of this is going to be kind of optional. I'm going to move through these kind of quickly because they are optional. And if you want to skip these, you can just jump to the end and look at the checkpoint problem. But I do want to talk about these next couple because they do come up and they can be helpful. Um, so the test for 3, we're going to take the sum of the digits that we have, and if that sum of the digits is divisible by 3, then the original number is divisible by 3. If the sum of the digits is not divisible by 3, well, then it's not. This is an iterative process, and by that I mean we could take the sum of the digits, and then if that sum we don't want to test, we could do the same test on that sum of the digits. And so whatever that number is we get by taking that sum, we can take the sum of those digits, then the sum of those digits, the sum of those digits, and you can keep going until you get down to a single digit number, and then you'll know whether or not 9 is divisible by 3 or not. So you can continue this process if that's something that you feel sort of inclined to do. So we'll take an example. 144. Is 144 divisible by 3? So if we add these digits together, we get 1 plus 4 plus 4. So that makes a 9. So this is divisible by 3. This absolutely works. And we could go through and divide it out. 144 divided by 3, that goes in 4 times, is a 12. 24 is an 8. So we can see that it's 3 times 48. So we see it's divisible by 3. If we compare this to 145, if I add these digits together, 1 plus 4 plus 5 equals 10, which is not divisible by 3. And then if I wanted, I could add those digits together and do 1 plus 0 is 1, which is still not divisible by 3. But this is what I mean by this iterative process. I can add those digits and, and keep going. So this is not divisible by 3, and so I could see this is 3 times 48 plus 1. It leaves a remainder of 1 when I divide by 3. So this is your test for 3. It's a little bit different from the others because you're not just looking at the ones digit. You have to take the sum of the digits. I'm not going to go into why this works. If you're curious about why it works, by all means, you can, come ask me after class, and I can tell you all about it. But yeah, just how it, the why it works, we're going to set aside. Just how to use it will be sort of most important here. The test for 9 works just like the test for 3. You take the sum of the digits. And then if the sum is divisible by 9, then so is the number. So is the number. All right. So we'll take our 144 again. And so we get 1 plus 4 plus 4. So that equals 9. So we know that 144 is divisible by 9. So if I divide this out, this goes in 1 time, 54, 16. So we know this is 9 times 16. So we can see that it is, in fact, divisible by 9. And, one of the neat things about this, you can take this rule and also use it to construct divisibility problems for students. So if we wanted to take a number like 3, 1, so that makes 4, 2 makes 6, 3 makes 9. So 3, 1, 2, 3. So we can kind of reverse engineer. We can kind of use the rule to develop a number. And this should be divisible by 9 because, 3, 3, and 1 plus 2 makes 3. So this should be divisible by 9. And if I check that, so 9 goes in here 3 times. That's 27. 42, so this goes in 4 times, is 36. So that's 63, and that goes in 7 times. So sure enough, that's 9 times 3, 47. So this rule can, like I said, help us find numbers that work for us to do what we need them to do. The divisibility test for 4 is very similar to the tests for 2, 5, and 10. But instead of checking the ones digit, we're going to check the tens and ones digits as a 2-digit number. And if that 2-digit number is divisible by 4, then the whole number is. And so if we take a number like 1724, then we're going to ignore the 1, 7 and just look at the 2, 4. Just look at the tens and ones place. And since 24 is 4 times 6, then we know the whole number is divisible by 4. Again, I'm not going to go into a lot of the reasoning why. It has a lot to do with the fact that this 17 is 17 times 100, and we know 100 is divisible by 4. And so it's the same idea of what we looked at before. We know everything in the hundreds place and beyond is divisible by 4. But yeah, it's the same idea. You just have to remember to check not just the ones place, but the tens in ones place. And this can be a little confusing for some students because they see something like 1734, and if they're thinking about the tens or twos or fives rule, they'll just check the ones place and see, well, this ends in a 4, so this must be divisible by 4. And if you look at the last two digits, you get 34, which you can tell, clearly isn't divisible by 4. So it can be a little confusing for some students, and then you get, a number like 1742, where the 2 is not divisible by 4. Oh, no, not 52 is what I'm looking for. 52. Where's my eraser? Not 42, 52. There we go. So the 2 doesn't work, but the 52 does, so that can be a little confusing as well. So, after they've done, 3 tests where it's just the ones digit, something involving more than the ones digit can be a little confusing, but, it's manageable. The last one is the test for 6, and the test for 6 is a good one because all the test for 6 is that it passes the test for 2 and the test for 3. So if it's even and divisible by 3, then we know it's divisible by 6. Man, that's it. Now, there's a subtlety to this. If a number is divisible by 2 and divisible by 4, it doesn't mean that it's necessarily divisible by 8. And the reasoning for this is because the 2 and the 4 share a factor. 2 and 3 don't share a factor. So there's a lot of subtlety to this. So if you don't feel comfortable explaining to students why 2 and 3 work, but why 2 and 4 don't, then maybe it's not something that you introduce, or maybe it's just something that you use for yourself. But we'll talk a little bit more about common factors here in the next couple sections. But I like this test because it allows us to start using these rules together, these tests together. But that's your test for 6. If we take a number like our 144, which we saw already, so we know this is even because it ends in a 4. So it has a 4 at the end. And we know it's divisible by 3 because the digits add to 9. So if it's divisible by 2 and by 3, then it's divisible by 6. So 6 goes into 144. 2 times 12, 24. There we go. So we know that this is divisible by 6. So here's your checkpoint question, and I'm gonna just ask you to look at the ones that are in the book. Now, if you want to apply this to other numbers, you certainly can. But is the number 3,210 divisible by 2, 5, and or 10? If you want to go through the 4, the 3, the 6, anything else, the 9, you're more than welcome to. But I'm just gonna ask you to check the ones that are in the book. As always, if you have any questions, please be sure and let me know. All right, thank you. Bye.